Alright class, let's look at chapter 3.1, quadratic functions, parabolas. The graph of the quadratic function f of x equals ax squared plus bx plus c is a parabola with the turning point called the vertex. The basic quadratic function y equals x squared. So this is a graph of y equals x squared. It hits the x-axis here at 0, hits the y-axis at 0 as well, so your minimum point here really is a 0, 0. And then it just kind of goes up in both directions. So that's your basic quadratic function y equals x squared. It's got the turning point 0, 0, like I said. From negative infinity to 0, the function decreases. From 0 to infinity, it increases. So starting this way and going this way until you get to 0, the function is going down, so it's decreasing. Now starting at 0 and going up, or going to the right, it increases. Okay, pretty easy to see from the graph. So, if we go over increasing and decreasing functions, a function f is increasing on an interval if for any x1 and x2 in the interval, when x2 is greater than x1, it is true that f of x2 is greater than f of x1. So, all that means is if I start here at 0, 0, so my x1 is 0, so my x2 is 2. So, x1, 0, x2, 2. So we'll say your x1's here at 0, your x2 is here at 2. That means your f of x here, or f of x1 here, is also 0. Same thing as your y, really. Your f of x of 2 here is actually, if you look at it, 2 squared will be 4. So as my number gets bigger here, my y also gets bigger, so it's increasing. And it works the other way around too. So if you went from negative 4 to 0, you would be getting smaller. So negative 4, your answer's over here somewhere, probably at a positive 16. And as you increase and go to x1 here, it goes down to 0. So that's the difference between increasing and decreasing. Pretty simple, especially once you look at the actual picture. Now the quadratic function y equals negative x squared has the form y equals ax squared, and a is less than 0, so it opens downward with a vertex of 0, 0. Okay, so if you're looking at that, and I'll just draw a small sketch over here. You can graph it on your calculator as well if you'd like. The calculator gives a really nice graph of it, but just a rough sketch of it. It looks just like the other graph. The only difference is if you've got a negative 1 out front, it just flips it so that your new graph looks like something like this. Obviously not perfect, but just a rough sketch. You can graph it on your TI really, really easy. Put negative x squared in your y1, you'll get a very nice picture of it on a standard zoom. Alright, so how about y equals 1/2 x squared? So, what would 1/2 x squared look like? So, let me try to do a little bit more steady-handed draw here. Not bad. Done worse. Okay. So it's got a positive coefficient out front, which means that it's actually going to go up. Okay. That negative coefficient made it frown down. Positive coefficient, 1/2 is positive. I was going to make it go up. The only difference here is if you wanted to do, say, an XY table, so you could figure out what is what. And you could also simply graph it on your calculator. That's a whole lot easier. If we did an XY, looked at negative 2, negative 1, 0, 1, and 2. Okay, if I plug negative 2 into this, negative 2 squared is 4. 4 times 1/2 is going to wind up giving you 2. Okay, negative 1 squared is positive 1 times 1/2 is 1/2. 0 squared is 0 times 1/2 is 0. And it honestly gives you the same thing here. So if I was graphing this, do it in blue, I would go, let's draw some tick marks so we know exactly where to put everything. Okay, so I'm going to graph this in blue. I'm going to go -2 and rise 2. Like I said, my graph's not going to be perfect. I'm going to go -1.5, so about right there. I'm going to go 0, 0, which is there. 1.5, and then 2 and 2 again. So that if I connect my dots, I get a parabola that looks something like this. Right, very similar to the first one. Still going up because I got that positive coefficient out front. The only difference between this and the very original one is that what happens is because our coefficient is smaller than 1, it kind of slows it down. So normally 1 would go to 1, 2 would go to 4, so you would be increasing a lot faster or decreasing a lot faster, but because we've got the half there, it kind of slows the rate down. Okay, the vertex, which is the point where the parabola turns, is a minimum point if a is positive, a maximum point if a is negative. The a they're talking about is that number in front of your x squared here. So if that a is positive, you're going to have a minimum point. If the a is negative, you're going to have a maximum point. The vertical line through the vertex is called your axis of symmetry. So you've got the axis of symmetry. The equation for it is x equals -b over 2a, where b is the number that's in front of your x, and a is the number that's in front of your x squared. Okay, so the vertex point of any of these parabolas will be, and it should have an additional parentheses that got left off here, looks like, but will be -b over 2a and f of -b over 2a. Okay, so if I wanted to find the vertex of this formula, all I would have to do is start with my parentheses. My b here is -4, so it'll go -4, okay, over 2 times -2. Okay, that would be your x point. Your y point would be f of -b times 2a. Okay, now the easiest thing to do is go ahead and simplify this so we don't have to plug this big massive thing into this equation for this part. So I'm going to simplify this first. Do it in green. -4, or -4 is a +4. Okay. 2 times -2 is a -4. 4 over -4 is -1. Okay. So that when I do this, I'm going to use the simplified -1 here for this piece. So it's going to be f of -1. And that'll be the vertex here. So what I need to do is to find this f of -1. I'm going to have to start with this formula here. -2 times -1 squared minus 4 times -1 plus 6. Okay, so -2 times -1 squared. Well, -1 squared, -1 times -1 is +1. So I'm left with a -2 here. -4 times -1 is a +4 plus 6. So if I simplify this, I should get an 8. So that the final vertex form here looks like -1, 8. And that would be the vertex of this parabola. And that's how you find it. Alright, example 1 says r of x equals -0.1 x squared plus 600x. It says find the vertex in the axis of symmetry. Okay, so the vertex is given by this point here. Alright, so let's try to see, change colors and stay consistent. So the vertex will be given by -b over 2a. So our b here is 600, so it'll be -600 over 2a. Okay, our a here is negative 0.1. Okay, and then the second part of that vertex is going to be f of whatever this is here. Like I said, instead of typing that whole big thing in this whole equation, what I'm going to do is go ahead and simplify it. Now, negative 600, right? Negative 600, did I put parentheses here and close this too? Negative 600 over 2 times negative 0.1. If you want to take your calculator, you can type that in. I'm fairly certain it's 3,000. Let's see. Divided by 0.1, double check. Divided by 2, yep, it's 3,000. Which kind of hints at what the f of it will be. So what I need to do here is I simplified that to 3,000, which is the same thing as what that equals. Okay. Now I need to plug 3,000 in this equation. Okay. So if I wanted to find this over on the side, kind of run out of space there, but you kind of followed what I did here. That's a 3 as well. Okay, so I've got negative 1 times 3,000 squared plus 600 times 3,000. If you do that, what you get is 900,000. So that this simplified would be that 3,000 comma 900,000. Okay. Now it also wants you to find the axis of symmetry. So what you got to know is, I always like to point it out, the axis of symmetry is essentially just your x point. So your axis of symmetry here is just x equals 3,000. So your vertex is 3,000 comma 900,000. Your axis of symmetry is just x equals 3,000. Okay. Now you need to know, is your vertex a max or a min point? Well, because our coefficient here, this negative 0.1 in front of this x squared, because it is a negative, that makes it a max. Because your parabola is going to be facing down like a frown. Okay. Graph the function and find some points. We'll go over to the calculator to do that. D says for what x values is the function increasing and decreasing. So let's take a minute to go over to the TI. We'll graph the function, and then we'll look at the values where it's increasing and decreasing. Alright, so what I've got here is I've got TI up. I'm going to Y1. Or to get there, all I got to do is hit the Y button. And I've typed in the formula. So negative 0.1 x squared plus 600x. Okay. Now, if you hit zoom standard, or if you're zooming in standard, you're not really going to see much, right? You can try zoom fit. So zoom fit is the 0. Still don't see much. I know it's a parabola, not a straight line, so this really doesn't help me either. So let's try to zoom out. And we're probably going to have to do it quite a bit. So I'm just hitting enter every time to continue zooming out. And eventually I get to where I'm pretty nicely zoomed out here. Okay, and I can see the curvature on both sides of the parabola. Okay, so you're probably going to have to do the same thing. Maybe your calculator's not as fast as mine, and you have to take a little time to zoom out. But if you zoom out, eventually you should be able to get a decent picture of it. Now, like I said, we can see now clearly that we've graphed it, that it's a max. I encourage you to use your calculator. It's a tool that's right there for you. So if you're having trouble memorizing some of these rules, sometimes it's just really simple. Just go ahead and graph the example they give you and answer it by the picture. That's perfectly fine. Alright, now it wanted us to find a few points. So I could draw a little XY table, do them all by hand, or I could say I'm a little smarter than that and I don't want to work that hard. So I'm going to go second table or second graph, just like you saw me do. All I did was hit the blue second button and graph. It takes you to a set of tables here. So if I want a few points on this graph, 0, 0 is a point. -1, -600.1 is a point. -2, -1200 is a point. 3, 1799.1 is a point. So you've got a whole list of points here. Okay. The other thing it asks for what values of x is it increasing or decreasing. If I look at the graph, right, we know that we have an axis of symmetry. We've already found it at x equals 3000. Now, the problem with this is graphing a horizontal line is not a really easy thing to do on the TI. But, because if you type in y equals 3000, you're not going to get the same line. It's not going to be the axis of symmetry. But what you can do is you can find that axis of symmetry and that vertex a lot easier with the calculator than you can doing it by hand. How do you do it? All you have to do is second calc. You see you have a maximum here. Your maximum is going to be your vertex, and the x value of your maximum is going to be your line of symmetry. So I'm finding a maximum here. I'll go left of the peak, which is right where it started. I'll go right of the peak, and then I'll guess where the peak is at, or the max is at. It tells me my maximum at x equals 3000, y equals 900,000, which is exactly what we found by hand. So this, if we drew a straight vertical line, we would have our axis of symmetry here. Okay. So our axis of symmetry is x equals 3000. Our vertex point is 3000, 900,000. Don't have to do all the math. You can just find it with your calculator now. Now, I do want to know where I'm increasing and where I'm decreasing. So I'm increasing. So from negative infinity all the way to this 3000, I'm increasing. From 3000 to positive infinity, I'm actually decreasing. I hope you see how that works. That pretty much covers it. You can honestly answer this whole thing with the calculator. Or you could do it by hand. Either way is fine. I like to show you both ways, but you have the calculator. You might as well use it, get used to using it, use the technology to your advantage. Let's go back over to the page and let's write up this last part. Move on to the next one. Alright, so I've already kind of wrote it on here. For D, we're increasing from negative infinity to 3000. We're decreasing from 3000 to infinity. You can write some points if you want to find some points here and write them. I showed you how to find them. It's really, really easy. The calculator does it all for you. Example 2. Using data from 1900 and projected to 2020, the percent of the U.S. population that was foreign-born can be modeled by the equation y equals, and it gives you the equation here, where x is the number of years after 1900. A says, during what year does the model indicate that the percent of foreign-born population was a minimum? B says, what is that minimum percent? Okay, we can solve this by hand. We have access to the TI. I'm going to take us over to the TI so we can solve this on the TI. We'll come back and write the answers on the page. Alright, so we're over here at the calculator. And I've got my y1 typed in. Go ahead and take a second to type yours in if you need to, but I just simply typed that equation that they gave us into our y1 here. Alright, now I'm going to go back and zoom at standard. I always like to start out at a standard zoom and then adjust accordingly. I don't even see the graph in the standard zoom, which definitely means that I need to zoom differently. So I'm going to zoom fit, which is the same thing as zoom 0. It doesn't look like a curve here. I need it to look like a curve, so I need to zoom out a little bit and try to get it within my window. Now, what I'm going to do is I'm going to scroll right. I'm going to scroll down because I want to see the minimum point. And it's getting me close to it. I'm going to do the same thing. I'm going to scroll right. I'm going to scroll down to the line. And I'm going to zoom out again. So all you got to do is hit enter again. It zooms out again. So now I can see a nice view here of the minimum. And that's really what's important in this problem. Now it had asked us, it said, during what year does the model indicate that the percent of foreign-born population was a minimum? Okay, so let's find the minimum. Second calc, minimum. We will go left of the minimum, hit enter. We will go right of the minimum, hit enter. And we'll come right back here, kind of guess where the minimum is at, hit enter. what we get is that our minimum is at a 68.37 approximately, and our y for that minimum is a 6.29. Alright, so let's take those values back to the page and let's use them to solve the last two problems of the question. So that minimum point we found was 68.37, comma, 6.29. So this is your x value, that's your y value. And that's kind of important in solving this problem. The reason it's important in solving this problem, A wants during what year does the model indicate the percent of foreign-born population was a minimum. Okay, X is the number of years after 1900. So the part that we're looking at is this 68.37. So if we take it just as we rounded it, the answer isn't 68.37, it's 1900 plus 68.37. Which is the same thing as 1968.37. Now typically they'll have you just round it to the closest year. If we do that, it's approximately, write the approximate sign, it's approximately 1968. Okay. Now B wants to know what the minimum percent is. So the percent of the U.S. population can be modeled by the equation y equals. So our y is our minimum percent. So our answer for B will be 6.29%. And that's why it's important to know what your x is and what your y is, and to make sure that you don't have to adjust your x value for whatever year it actually started with. Easy enough. Example 3 says a ball is thrown upward at 64 feet per second from the top of an 80-foot high building. Okay, and so you have the formula for it. You got this S of t equals negative 16 t squared plus 64t plus 80. A says find the t coordinate and the s coordinate of the vertex of the graph of this quadratic function. Okay. B says graph the model. C says explain the meaning of the coordinates of the vertex of this model. Okay, so let's do this. Let's just go ahead to our calculator. We're going to graph this model. We'll find the vertex from the graph, and we'll talk about what the coordinates of those vertexes, or that vertex, means for this model in this word problem. So let's go over to the TI. Alright, so we're at the calculator. I've got it typed in. I just substituted X for my T's, and it graphs the same way. So I'm going to hit zoom standard. Like I said, I always like to start in a standard zoom. I can tell that, it looks okay, but I really need to see that max or min. So I'm going to zoom out. And I'm just going to zoom out one time. I'm going to zoom out again. I can see that I have a max there. Maybe it isn't that good of a view. Okay, so if I want to kind of adjust it and make it look better, something that's really easy to do is just take your cursor. You can see here that the if I move to the left, negative 10 would probably be a good bound here. If I move to the right, a little bit past this, looks like 15 would be a good bound there. So let's change our window up a little bit. We'll go from negative 10 to 15. And we'll graph it. And that looks a whole lot better. I can see the curvature of the graph. I can see that I have a maximum here. So let's figure out what that maximum is. If I do second calc, I calculate the maximum. I'll go left of the max. I'll go right of the max. And then I'll guess the max. And it tells me the maximum is at essentially 2 and 144. Now, the thing that it really wants you to do here, it wanted you to graph it, it wants you to give the t coordinate and the s coordinate, and it wants you to explain the meaning of the vertex for this graph, or for this model. So keep your calculator up. I'm going to go back to the page. I'm going to write this vertex down. We'll discuss what goes where and what goes with what. But keep this picture up on your calculator, or come back to it if you need to. If you need to rewind the video and come back and see what it looks like, do that as we discuss the picture to finish off the problem. Alright, so I'm going to go back and I'm going to read the question again. It says a ball is thrown upward at 64 feet per second from the top of an 80-foot high building. The reason I told you to keep your graph up is if you'll look right there at x equals 0, you will notice that the line actually hits at y equals 80. Okay, and you could trace and see that if you needed to. But essentially you're standing on the top of that 80-foot tall building and you're throwing a ball up and then it's coming back down. Okay. Now, how that plays into effect is, I'm going to go ahead and explain the vertex here because we already found it, is that essentially at 2 seconds, your ball is 144 foot tall, or that's the height of your ball, right? And then after that, it comes back down. So from those 0 seconds, it's going and increasing from 80 foot to 144 foot, and then after those 2 seconds, it goes down and hits the ground. Right, and you can find the point at which it hits the ground if you wanted to as well by finding a 0 of the graph. Alright, so the big thing here that I want to push to is you need to find your t-coordinate and your s-coordinate. Well, that 2 is your t-coordinate, then that 144 is your s-coordinate. Okay, because remember we substituted the t with an x, so t and x are essentially the same thing when we typed it in our ti, so that our y is the same thing as our s here. Okay, so at time 2, we were at a height of 144 feet. And we've already explained what the model meant. Now the next thing we'll look at here is the vertex form of a quadratic function. So we've got y equals a times x minus h squared plus k. That is the vertex of the parabola is at hk. Okay, it's important to know that you got to have that negative there, because if you mess that up, you'll mess the whole problem up. So if we use this equation here, we need to find the vertex. So the vertex is hk. We've got the negative here, which means that my vertex is simply 2, 3. Easy enough. Okay. Couple rules here. Parabola opens upwards. If a is greater than 0, the vertex is a minimum. Parabola opens downward. If a is less than 0, the vertex is a maximum. 3 says the axis of symmetry of the parabola has the equation x equals h. Okay, so this h in your equation up here, if it's in the vertex form, is also going to be the axis of symmetry for this parabola. So your axis of symmetry for this one would be x equals 2. Okay, that would be your axis of symmetry. Axis of symmetry. I'm just going to abbreviate symmetry with SYM. Okay. 4 says if A is the same as the leading coefficient, or the A is the same as the leading coefficient, and y equals ax squared plus bx plus c. So the larger the value of the absolute value of A, the narrower the parabola will be. Essentially, the bigger A gets, the skinnier your parabola gets. So we've got some examples to look at. Let's look at these two examples. I'm going to go to the calculator, type both of these in, and we will kind of compare the two, and you'll get to see the effect of what we're talking about here in number 4. So let's go over here and do that. Alright, so if I come over here and look at this, I've got my y1 and my y2 typed in. If you need to take a second to type those in, please do that. They're essentially the same equation except for this coefficient out front. So let's see how that comes into play. I'm going to zoom standard on them. If we got to zoom out, we'll do that. So there's the first one, there's the second one. Pretty decent zoom on it. So as you can tell, this first one, this blue line, which corresponds, if you need to look back, to the one that's got the bigger coefficient out front, that 2. There's an imaginary 1 sitting in front of this one, of course. It's a skinnier or narrower graph, which corresponds exactly to what that last point I made was. The bigger that coefficient, the skinnier your graph gets, or the narrower your graph gets. So that comes into play really nice and easy. Okay. Other than that, like I said, they both actually have the same minimum point. You know, and you can play around with your graph and find points and look at points. And a cool thing you can do with your graph is you can do second table, and you can kind of scan through your points here. So you can see they've got this 1 point in common here, 2 points. Nope, not 2 points in common. But they've got this 1 point in common here, this 2, 3, and 2, 3. I feel like that's probably the minimum point that we're looking at here. Yep, looks like the minimum point there, 2, 3. That's the only point they have in common. But those are your two graphs. You can look at as many points as you wanted to for them, and you can find that minimum for both of them if you needed to, with the min function if you want to be precise. So let's get back to the notes. Alright, example 5 says the cost for producing X champion golf hats is given by the function c of x equals 0.2 times x minus 40 squared plus $200. Let's find the vertex of the function. Is the vertex a maximum or minimum? Okay, now you can graph this if you want to find that. There's really no need. The vertex is just hk. Hk in this case is just 40, comma, 200. Okay, that's easy enough. Alright, is the vertex a max or a min? Now I have a positive value here. Okay, I've got a positive value out front for my A, in which case we're going to have a minimum. Okay, that's something you need to know. If I have a positive A, it's a minimum. If I have a negative A, it's a maximum. C says describe what happens to the function between x equals 0 and the x coordinate of the vertex. Okay, what does this mean in the context of the application? So, alright, without graphing this, okay, and you can go back and you can graph it on your TI. I know some of you are probably itching and already doing that already. That's perfectly fine. I always encourage you to get a picture to look at it. It really does help to do that sometimes. But let's try to visualize this without the TI and not rely on it that much. If after we're done with this one you want to type it in and look at it, I actually do encourage that. C says, like I said, what happens between x equals 0 and the x coordinate of the vertex. So we're really looking to see what happens between 0 and 40. 0 to 40. Okay. Now, if I have a minimum here, right? Alright, just think with me now. If I have a minimum, that means it has to go down and then come back up. So if I have a minimum looks like this, right? My vertex is here at 40, right? Which means that 0 is somewhere floating around over here, which means from 0 to 40, we're decreasing, right? So what happens between x equals 0, the x coordinate of the vertex? It decreases. If you need to look at the graph to see that, that's fine. Like I said, by all means, take whatever advantage you need to, because you can use that TI-84 throughout this entire course. So if you like to look at it, you like to type it in, you like to see it right there in front of you, makes you feel comfortable, helps you interpret it, by all means use it. But what does this mean in the application of the problem? It means that if you're going to buy champion golf hats, if you're buying a low volume of champion golf hats, it's going to cost more per hat than if you're buying a higher volume up to a certain point, and then it starts back to increasing. Okay, so if I'm only going to buy, say, and you can look at your graph if you want to, but if I'm only going to buy, say, 2 hats, those 2 hats are going to be so much more expensive than if I was purchasing 30 hats, right? At least per hat. Okay, so you'll notice this a lot of times when you order stuff online. If you're only ordering 1 or 2, they might cost $5 a piece. If you're ordering 10,000 of them, they might only cost 5 cents a piece. A lot of times with bulk orders, the more you order, the cheaper they get. So that's kind of exactly what happens here. And I encourage you to go back up here, graph this in your TI, and have a look at it. Alright, example 6. It says if the points in the table lie on a parabola, write the equation whose graph is the parabola. Okay, so there's a few ways to do this, and I'm going to show you both ways, I think. So if I'm looking at this, okay, so if I come over here and I graph it, let's sketch it out first. So I'm going to do the best I can to sketch it. I'm going to go by 5s on my Y. So this will be -1. I'll go by 1s here. That's 0. This is 1. This is 2. I'm going to go by 5s on this one. So I'll go 5, 10, 15, and then I'll go 5, 10. Okay. So that what I'm looking at here, if I'm just rough sketching it, I've got a -1, and then I'm going to go up to 13. So it's about right, say here. I've got a 0, -2. So -2, not quite at -5, so it's somewhere around in there. I've got a 1, -7, which gets down there closer to that -10. I've got a 2, -2. So 2, and it's going to be down here at -2, which is right there, right? So what I'm seeing, I did a absolutely horrible job of graphing this. This one should come over a little bit. But what I'm seeing is, at least in this rough sketch, I'm seeing a parabola that kind of looks like that. Okay. Alright, so the vertex form here, if we do it, we get y equals a times x minus h squared minus, plus k. Okay. Now, what I notice here is my vertex here looks like it's 1, -7. Okay, so that's what I'm going to plug in. So I've got y equals a times x minus 1 squared plus -7. So I'm just going to go ahead and write that as a -7. Oops. Okay, but I still need to figure out what this a is. Okay, so there are a few ways to do this. The easiest way that I know to do this is, if I was going to choose a point, because you can choose a point over here to plug in for x and y, if I was going to do that, I would either choose a point that canceled my squared part out here, or either was a 0 and was easy to work with. Let's use this one. Let's use 1, -7, because that'll cancel this whole squared part out here. So my y here is -7. That equals, it's bad to use the vertex, because if you use the vertex, it's probably not going to work out the way you want it to, because if you cancel out this part right here, gotcha. If you cancel out this part right here, you're not going to find the a, because you're going to have an a times a 0. So don't use the vertex. Gotcha on that one. So what I actually need to use, let's use this one. Okay, let's use 0, -2. Don't want to cancel out that a, we want to find that a. So y is -2 will be a times 0 minus 1 squared minus 7. Okay. Alright, so 0 minus 1 squared is going to be a -1 squared, which is a +1. So I get -2 equals essentially just an a minus 7. Okay. I add 7 to the other side, I get that a is 5. Okay. So that the final form of my equation in vertex form here is y equals 5 times x minus 1 squared minus 7. Alright, now there's another way you can do this on the calculator that is actually a whole lot easier, but I wanted to show you the hand method first. The only thing about the calculator is if they want it in vertex form here, it's not necessarily as straightforward, but I'll kind of talk you through it. Okay, we know how to do the vertex form though, and the calculator can actually help you find that a. So I'm going to bring over the calculator real quick, kind of explain it to you. Alright, so if you're at your TI, you hit the stat button here, and you hit edit. You can type your list in. I got L1 as your X, L2 is your Y. Now I'm going to hit stat. We're going to go over to calc. We've done linear regression, but we're not talking about a line here. We're talking about a quadratic. So we're going to do quadratic regression. If we do that, you can store it in Y1 if you'd like to with the vars button, just like we were doing with the linear regressions. But we'll calculate it. And it doesn't give it to us in vertex form, it just gives it to us in the standard quadratic form, which is y equals ax squared plus bx plus c. Okay. Now, like I said, if they ask for it in vertex form, what you can do with that same property that we learned earlier in this lesson is the a's always stay the same. The b's and the c's will change, switching from your regular standard form here to vertex form, but your a always stays the same. So if you know that you can write it as y equals ax squared plus k, so y equals ax minus h squared plus k, trying to say that all out really clear. That a that's out in front is going to be a 5 regardless, just like it was in our problem. So if you're just trying to find the a because you already know the h and the k for the vertex form, you can use your calculator to find that if you have the points. Otherwise, if they don't care about the form, you can just give it in this form. But the question will tell you how it wants it. So we will do a lot more quadratic regression throughout the rest of this chapter, and we'll get more into it. But this was just a very brief introduction to it. Alright, so let's look at this one, the very last one on the page. It says put y equals 2x squared minus 8x plus 5 into vertex form. Okay, so we know our a here is going to be 2. Easy enough. So just off to the side, we know our a is going to be equal to 2. Our vertex form is y equals ax squared, so 2x squared, x minus h squared, sorry, I'm leaving out the h's, plus k. Okay, now, we don't really know what these h's and k's are necessarily here, but there's a pretty easy way to find it, okay? And I don't know why I put a 5 there. It's not a 5. It's a k. I was thinking k, writing 5. Saying k and writing 5. Okay, so let's figure out what these h's and k's are. Now we can find the vertex of the parabola. We have the equation for that. Remember, it was negative b over 2a. Our b here is negative 8. Okay, so it'd be a negative 8. 2a here. Our a here is 2. So that's actually going to be a positive 8 over 4, which is the same thing as 2. So our h is a 2 as well. So we get y equals 2 times x minus 2 squared. Now we just have to figure out what this k is. Okay. Still need to solve for this k. All we got to do is take this point 2 and plug it in to our y form here, and that'll be our k. So what I'll do, I'll change colors real quick. If I go from this original equation, so y equals 2 times 2 squared minus 8 times 2 plus 5. Now simplify it, because 2 squared is 4 times 2 is 8. 8 times 2 is 16. And then we got a plus 5. So if we simplify this out, let's see what we get. 8 minus 16 is negative 8. And negative 8 plus 5 is what? Negative 3. So our k equals 3. Negative 3. Remember up here we found that our h was equal to that too. Okay, already plugged that part in. So if I get my finalized equation here, I get y equals 2 times x minus 2 squared minus 3. And that is the same equation. Don't believe me? Type both of them into your calculator. You can type, let this one be your y1, let this one be your y2, and they should graph out to be the exact same line. If not, send me an email, let me know I was wrong. I'm pretty sure I'm right. but it wouldn't be the first time I was wrong because everybody makes mistakes. Alright, so we just finished chapter 3.1. Go do the accompanying homework. Let me know if you have any problems. Other than that, hopefully you found this pretty easy and simple to get through and can jump right into chapter 3.2 whenever you get the chance. Thank y'all, and I will see you at the next chapter.